acceleration is the rate at which velocity changes. So if I want to find the average acceleration, I can take my change in velocity over change in time, and that should give me my average acceleration. So that's final velocity minus initial velocity divided by my final time minus my initial time. One thing to note is that accelerations aren't necessarily in the direction of velocity. For example, if we have a train here that's pulling up to a station, the velocity is coming towards us. But as it's slowing down, the acceleration is going away from us because the velocity is getting slower and slower. So acceleration and velocity don't have to be going in the same direction. As the train leaves the station, it will now accelerate in the same direction as it's leaving. Let's consider an example of a racehorse. Coming out of a gate, accelerating from rest to a certain velocity of 15 meters per second due west in 1.8 seconds. So what's the average acceleration as it does this? Well, we'll use our formula. Average acceleration is my change in velocity. My final velocity is 15 meters per second. And my initial velocity is from rest, means we start from a velocity of 0. This will be important. Anytime we're talking about starting from rest, that means my initial velocity is 0. And then that happens in a time interval of 1.8 seconds. So if we say our initial time is 0, my final time is 1.8 seconds. So 1.8 seconds is the time interval minus 0. And a lot of times we'll try to specify things, if we can, so that we start at position x equals 0 at time 0. That's not always the best choice, but it's frequently a convenient choice, and it happens to make sense here. Here, actually, we didn't care about position. This is just velocities, but should work out. We divide those, and we get 8.33. If I can read my handwriting. The units on this, meters per second, or meters per second squared. So that means on average, we're speeding up by 8.33 meters per second every second. Now this is an acceleration, so we need a magnitude and a direction. The direction will be the direction of that initial velocity, which is westward. So that's the average acceleration. And I have a little space here, so I'll point out that if you had defined your x direction in the positive direction, or in eastward, then this would be in the negative eastward direction. So you could have written this as negative 8.33 meters per second squared eastward. And again, that's if we had defined my x as being positive that way. These two statements are equivalent.